Imagine for a second that you are trapped in a two-dimensional world.
Like completely anchored to the floor.
Exactly. You are physically anchored to the floor. You're completely unable to move upward to save your own life, honestly.
Wow, that sounds terrifying.
Right. Your entire universe consists of the ground beneath you, and you're basically at the mercy of whatever happens to fall from the sky.
Right, you just have to wait for things to drop.
Yeah, but then one day your body suddenly grows this internal balloon that just unlocks gravity itself.
Just completely rewrites the rules.
Exactly. You don't just figure out how to jump. Your fundamental relationship with physics is rewritten, and this whole three-dimensional universe opens up before you.
I mean, it sounds like the plot of a science fiction movie, really.
It totally does.
But what you're describing is actually a surprisingly common, yet completely invisible biological miracle. And it's happening right in our own homes.
We just don't notice it.
No, we don't.
Yeah.
Mostly because it's dressed up as a daily chore, you know.
Yeah, which brings us to why we're here. Welcome to this deep dive. We are thrilled you're here with us today because we have a very specific, incredibly focused mission for this one.
A really fun one, too.
Definitely. We are going to take a microscopic look at a seemingly mundane daily routine feeding pet fish and uncover a massive aha moment about biological development.
And physical mechanics, too.
Yes, and major behavioral shifts. We are looking at this short but just profoundly insightful excerpt from a blog. It's called Notes on Fishkeeping.
Such a great resource.
It really is. Specifically, we're looking at part 246. It's authored by someone who goes by Ang, and it was published exactly today, May 1st, 2026.
It is a beautifully concise piece of writing. I mean, in just a few lines, we get a front row seat to a complete biological and behavioral revolution.
Right inside a glass box.
Exactly. It is the perfect case study in how physical maturity fundamentally alters how an organism interacts with its entire world.
Okay, let's unpack this. In this particular tank, there's a spawn of fish currently going through a major transitional phase.
Right, they're growing up.
Yeah, and for anyone listening who might not be deep into fish breeding, we're talking about the transition from the fry stage into juveniles.
Which is a huge leap.
It's massive, and it's important to clarify that a fry isn't just a slightly smaller version of an adult fish. It's essentially a larval stage.
They are biologically distinct.
Right, and frankly, they're completely unequipped for the world. But suddenly, in this transitional phase, a dramatic change occurs. These fish start surfacing to feed on food pellets directly.
Which I know sounds incredibly simple, like, oh, they swim to the top to eat. Big deal.
Right, it doesn't sound revolutionary at first glance.
But to understand the absolute magnitude of this shift, we have to establish the baseline. And we have to look at the frustrating, incredibly labor-intensive reality of what was happening in that tank before this.
Yes. The before state. So previously, the simple act of feeding these fish required manual intervention every single day.
Like serious effort.
Yeah, someone literally had to agitate and stir the water every single time food was dropped in.
Just stirring it up.
Right. And the entire purpose of that stirring was simply to force the food to sink down to the bottom of the tank so the fry could actually reach it.
Because they couldn't get it otherwise.
Yeah, but I have to admit, I didn't quite get this at first. I mean, if I drop a sandwich on the floor, I'm going to pick it up.
Sure.
If food is floating literally an inch above their heads, why were these fish just sitting at the bottom waiting to starve? Like, were they just too weak to swim up? Is it a laziness thing?
Well, what's fascinating here is the precise terminology used in the source to describe that earlier phase. Ang calls them instinctive bottom feeders.
Instinctive, so it's hardwired.
Exactly. That word, instinctive, does a lot of heavy lifting there. This was not a choice.
They weren't just being lazy teenagers.
No, not at all. They weren't just waiting for room service, you know. In their earliest stage of life, the bottom of the tank was their entire biological reality.
Because they physically couldn't leave it.
Right. They lacked the internal anatomy to maintain neutral buoyancy. So without constant, exhausting physical exertion, they would literally just sink like stones.
Man. So they were functionally trapped in a two-dimensional plane at the very bottom of the tank.
Apparently trapped.
Which means stirring the water wasn't just a convenience for them. It was literally a life-saving mechanism.
It absolutely was.
Because they physically could not cross the distance between the floor and the surface.
Precisely. The external environment, meaning the humans stirring the water, was artificially bridging the gap.
Bridging the gap between where the food was and where the fish were stuck.
Exactly. It bridged the gap between where the calories naturally floated and where the organisms were biologically confined. Without that intervention, The physical mechanics of the water column would have kept the food forever out of reach.
Okay, but suddenly, the manual stirring isn't needed anymore. Eng notes they don't have to do it. The fish have broken out of that two-dimensional plane and they're surfacing on their own.
Which is incredible.
But, I mean, you don't just decide to defy buoyancy through sheer willpower, right? So how did they physically overcome that limitation?
Well, they underwent a massive biological breakthrough. They developed functional swim bladders.
Okay, swim bladder. I love this concept because it feels so incredibly mechanical.
It really is.
So if we use a submarine analogy, a submarine has ballast tanks, right? It takes in water to sink, and it forces that water out to rise.
Right.
Is the swim bladder basically a submarine's ballast tank finally coming online for these fish? Like, are they just inflating a balloon and bobbing to the top? Is it an active process?
So the submarine is a brilliant analogy, but the mechanism inside a fish is actually far more complex and way more active than just inflating a basic balloon.
Really? How so?
Well, a submarine uses compressed air from steel tanks to blow water out of its ballast.
Right.
But obviously, a tiny juvenile fish doesn't have a tank of compressed air hidden inside its body, right?
No, definitely not. So where does the air come from?
It uses a highly specialized network of blood vessels called the gas gland.
Wait, what? They are filling an air sac using their own blood.
Yes, it's wild. As blood flows through this highly concentrated web of capillaries, the fish's body secretes lactic acid into the bloodstream.
Okay, lactic acid, like what we get when we work out.
Exactly like that. And
Okay.
its sudden spike in acidity causes the hemoglobin in the blood to abruptly dump its dissolved oxygen.
Oh, wow. So it just forces the oxygen out of the blood.
Right. And then that oxygen gas diffuses directly into the swim bladder, inflating it.
That is absolutely mind-blowing. They are literally pulling dissolved gas out of their own circulatory system to manipulate their specific gravity.
It is a chemical marvel, really.
But if they're pulling gas from their bloodstream, that must take some time, right? It's not like hitting an instant elevator button.
No, not at all. It takes time, it takes energy, and it requires continuous regulation. Eng's text specifically highlights that this development gives the juveniles full control over their buoyancy.
Ah, full control, not just floating.
Exactly. It's not passive floating. If they just passively inflated, they would bob straight to the surface and just be stuck there.
Which would be just as bad as being stuck at the bottom.
Exactly. So by actively regulating the gas exchange between their blood and this bladder, they achieve a progressive functional mastery of their own physics within the water column.
They can neutralize their weight perfectly.
Yes. They have unlocked the z-axis.
Unlocking the z-axis, I love that phrasing. Suddenly your universe expands vertically. You aren't just crawling on the floor anymore. You are navigating a true three-dimensional space.
It changes everything about how they live.
But having the physical ability to float to the top doesn't necessarily explain why they are suddenly doing it so aggressively.
Right, there's more to it.
Yeah, going back to our submarine analogy, a submarine with functioning ballast tanks can move up and down, sure, but it still needs sonar to actually find its target. It needs a reason to go to a specific depth.
Exactly. The swim bladder and the buoyancy control, those provide the how. But something else has to provide the why.
The motivation.
Right. And that brings in the next massive piece of this developmental puzzle, the evolution of their sensory perception.
Oh, here's where it gets really interesting. The source observation from Eng notes that alongside this physical development, these juvenile fish have sharpened their senses.
Yes.
And it gets very specific. They are instantly detecting the oils and scent radiating from the food pellets up at the surface.
And to really appreciate how profound this is, if you're listening to this and wondering why a fish's sense of smell matters so much underwater, you have to remember that chemical detection in a liquid environment works entirely differently than in the air.
Right, because water is so dense. Like if I bake cookies in my house, the smell wafts through the air relatively quickly. I can smell it in the living room.
Exactly.
But underwater, how does that actually work with a pellet?
Well, when a solid food pellet hits the surface of the water, it begins to hydrate immediately.
It gets soggy.
Yeah, and as it breaks down, it leaches highly concentrated lipids, amino acids, and oils right into the surrounding water. These chemicals create a diffusion gradient. It's basically a physical plume of scent traveling through the water column.
Like an invisible smoke signal.
That's a great way to picture it. And the juveniles have developed the specialized olfactory receptors required to read this chemical map.
And the speed of that reaction is what really stands out in the blog post. Eng emphasizes that they can pinpoint the food quickly.
Super quickly.
We are talking about a massive, sudden shift from a state of total dependency to extreme capability. I mean, yesterday, they were blindly waiting at the bottom for mashed up food to magically fall from the sky.
Just hoping it arrives.
Right. And today, they're actively tracking down a chemical gradient.
It completely transforms their ecological role.
Mm.
When they were fry, anchored to the bottom by their own physical density, they were entirely passive receivers.
Completely helpless.
But as juveniles, by putting these two milestones together, the physical mastery of the swim bladder and the sensory capability to map those chemical plumes, they become active hunters.
You can just picture the sheer chaos of it. Before, a pellet hits the water, and nothing happens until the human physically stirs the tank. It's quiet.
Boring, even.
Yeah. But now, a pellet hits the surface, the oils start to bleed out, creating that invisible chemical trail. And instantly, these tiny juveniles detect the gradient, engage their gas glands, pull oxygen from their blood, adjust their buoyancy, and navigate straight up the z-axis to the exact source of the smell.
They are no longer waiting for the environment to happen to them. They are actively manipulating their position to exploit the environment.
Which means that passive communal waiting game at the bottom of the tank is entirely gone.
Oh, long gone.
If everyone suddenly has the biological tools to swim up and the sensory tools to smell exactly where the food is, that quiet little society is going to turn into an absolute war zone.
Oh, absolutely.
Which leads us to the behavioral impact of all this. So what does this all mean?
Well, if we connect this to the bigger picture, the most profound takeaway from this entire observation is the fundamental shift in the nature of these animals. Ang explicitly notes that these fry switched from being bottom feeders by instinct to surface feeders by habit.
Instinct versus habit. That is a massive distinction. We use those words interchangeably a lot in daily life, but scientifically they are worlds apart.
They are entirely different neurological drivers. Instinct is an evolutionary inheritance.
It's in the code.
Right. It is a hardwired behavioral imperative that took millions of years to encode into their DNA. For these fry, their instinct, their absolute default setting was to dwell at the bottom.
But a habit is different.
Very different. A habit is an environmentally learned behavior. It is a neural pathway forged through repeated exposure to a specific stimulus and a specific reward.
Got it. So the stimulus being the pellet hitting the water and the reward being the calories.
Exactly. The human caretaker continuously dropping pellets strictly on the surface created a rigid environmental condition.
Right.
The biology gave the fish the tools, the swim bladders and the sharpened senses, but the environment dictated entirely how those tools were deployed.
That is incredibly heavy when you think about it. The environmental conditioning literally overwrote a survival instinct.
It did.
They didn't just learn a neat little trick. They suppressed millions of years of evolutionary hardwiring because the immediate environment taught them that waiting at the bottom was a losing strategy.
They realized neurologically that utilizing their newly developed tools to go straight to the source was the only way to maximize their calorie intake. The habit overwrote the instinct.
And you can see the absolute intensity of that new habit in the final outcome. Because they have learned this, and because they can pinpoint the oils so quickly, they are actively, as Zhang describes it, racing to the surface to get the first bite.
The first bite is everything.
It's a completely new paradigm. It is no longer just about eating to survive. It's about outcompeting every single sibling in that tank.
It is the birth of fierce competition.
Yeah.
By combining their physical maturity with that environmental reward system, they've transformed their society from passive coexistence into an aggressive surface hunting arena.
A total shift in dynamics.
And that first bite is the ultimate reinforcement of the habit. Every time they win that race, the neural pathway of the new habit gets thicker and stronger, pushing the old instinct further and further into the background.
It's just wild to me. We started this deep dive talking about someone being relieved they didn't have to manually stir a fish tank anymore. A totally mundane chore.
Just daily maintenance.
Yeah. But when you apply a microscopic lens to it, it is this perfect, dramatic intersection of mechanics, sensory evolution, and the psychology of habit formation.
All happening in a little glass box.
Exactly. You get the gas gland inflating the bladder, you get the olfactory receptors mapping the oils, you combine it with an environmental trigger at the surface, and suddenly you have a completely different animal.
It serves as a powerful reminder of how incredibly dynamic and reactive life is, even in a contained artificial system like an aquarium. Biological development isn't just a matter of an organism getting larger in size.
No, it's a total overhaul.
Right. It is a fundamental reorganization of how that organism interacts with the physics, the chemistry, and the social dynamics of its world.
Which really brings it all back to you listening to this right now. Think about your own habits, your own
It's
routines.
a great parallel.
It makes you wonder how often we completely miss these tiny progressive shifts happening around us, or even inside ourselves. When do our own hardwired instincts get subtly overwritten by the habits that our environment or our technology pushes us into?
Oh, that's a great point.
What tools do we have right now that we aren't using because our environment hasn't rewarded us for them yet? That is the joy of really paying attention. Noticing the profound mechanics hiding inside a simple daily chore.
It is a phenomenal realization to pull from such a concise observation from Ang's blog. And yet, looking strictly at the mechanics of what happened in that tank, this raises an important question.
Oh.
One that I think is worth considering long after this discussion ends.
Oh, I love a good thought experiment. Lay it on us.
Well, according to the specific sequence of events documented here, the fish became surface feeders by habit explicitly because the food was consistently delivered at the surface.
Right. The human dropped it there.
The environment shaped the application of their new biology. So imagine an alternate timeline. What if, from the very beginning, a completely different feeding mechanism had been used?
Like what?
Say, a tube that automatically delivered the food pellets exclusively to the bottom of the tank, totally eliminating the need for stirring, but keeping the food permanently at the floor.
Okay, so the food is always at the bottom. The environment never forces them to look up.
Right. If the environment never offered a reward at the surface, would these juveniles have ever developed this aggressive surface racing habit?
Oh, wow.
They would still possess fully functional swim bladders. They would still possess sharply tuned olfactory senses capable of tracking those chemical gradients, but without the environmental pull to the surface, would their deepest evolutionary instincts have kept them anchored to the floor forever?
That is so interesting.
Would they live their entire lives completely unaware of their own biological potential to rise?
Man. An alternate timeline where they have all the tools to fly, but the environment convinces them they can only walk. Are we bound by our instincts, or are we just waiting for the exact right environmental trigger to finally use the biology we already possess? That is a brilliant thought to chew on.
It really makes you think.
It sure does. Thank you all for joining us on this deep dive. Keep paying attention to those completely mundane daily routines. You never know what kind of structural, evolutionary shifts are happening right in front of your eyes. Until next time.